Hello, all. I'm Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. And in this Jan 2025 lecture series, we are discussing about the relationship between pixels in image processing. And already we have discussed about connectivity, path, and neighborhood of pixels. And now we are going to discuss about boundary in pixels. What is the use of boundary here? Actually, boundary detection and region-based segmentation, it plays a vital role in biomedical applications to solve diagnostic problems and to solve practical problems arising while taking imaging. Here, it is used to solve imaging modalities problems. Using particular algorithms, we can solve the issues here. And here the boundary, here R is subset or a subset of pixels. R is a region if R is a connected set, and it's a boundary, border or contour is a set of pixels in R that have at least one neighbor not in R. H can be the region boundary in binary images. See the example. See here the boundary Ri and Rj. See the boundary value. Your first primary point is two regions of ones that are adjacent if 8 adjacency is used. Second one, the circled point is part of the boundary of the one valued pixels only if 8 adjacency between the region and background is used. Third one, the inner boundary of the one valued region does not form a closed path, but its outer boundary does. See the first one, second one, and the third one. Two regions of ones that are adjacent if 8 adjacency is used. Second one, circle point is a part of boundary, one valued pixels of adjacency between region and the background is used here. Third one, the inner boundary of the one valued region does not form a closed path, but its outer boundary does. See the examples A, B, and C. See the distance measures for pixels P, Q, Z with coordinates X, Y, S, T, U, V. D is a distance function or metric. If D of PQ greater than 0, D of PQ is equal to 0 if P equal to Q. D of P comma Q, it is equal to D of QP, and D of P comma Z, it is less than or equal to D of P comma Q plus D of Q comma Z. See the Euclidean distance DE of P comma Q, it is equal to x minus s the whole square plus y minus t the whole square whole power 1 by 2. Points here, pixels having a distance less than or equal to r from xy are contained in a disk of radius r centered at xy. See the D4 distance, city block distance. D4 of PQ, it is equal to modulus x minus s plus y minus t. Forms a diamond centered at xy. Example, pixels with a D4 less than or equal to 2 from P. See the example, it forms a diamond centered at xy. D4 equal to 1 are the 4 neighbors of P. Okay, D8, it is a chessboard distance. D8 of PQ, it is equal to max of modulus x minus s comma modulus y minus t. Here it forms a square centered at P. For example, pixels with a D8 less than or equal to 2 from P. See here it forms a square centered at P. Chessboard distance. Here D8 equal to 1 are the 8 neighbors of P. See the previous one. D4 distance, city block distance. It forms a diamond centered at xy. Here D4 equal to 1 are the 4 neighbors of P. Here it forms a square centered at P, and here DH equal to 1 are the 8 neighbors of P. See the difference? Here in distance measures, D4 and D8 distance between P and Q are independent of any paths that exist between the points because these distance involves only the coordinates of the points regardless of whether a connected path exists between them. See. However, for M connectivity, the value of the distance length of the path between two pixels depends on the values of the pixels along the path and those of their neighbors too. See, For example, assume P, P2, P4 is 1, P1, P3 can have either 0 or 1. See, P1 and P3 are circled here. If only connectivity of pixels valued 1 is allowed and P1 and P3 are 0, the M distance between P and P4 is 2. If either P1 or P3 is 1, the distance is 3. If both P1 and P3 are 1, the distance is 4. P1, P2, P3, P4. The distance is 4. See, for pixel P, Q and Z with coordinates x, y, st and uv, d is a distance function or metric. Here, d of PQ greater than 0 if d of PQ equal to 0 and if and only if P equal to Q. D of PQ is equal to D of QP. Here d of P comma Z less than or equal to D of P comma Q plus D of Q is Z. For example, equivalent distance, we have the formula like dE of PQ is equal to root of x minus s square plus y minus t square. Root of x minus s square plus y minus t the whole square. See, D4 distance, already we have seen the city block distance. Here we are going to see another example. D4 of PQ it is equal to modulus of x minus s plus modulus of y minus t. See here, pixels with D4 of P equal to 1 is the 4 neighbors of P. See the example. See the second one. D8 chessboard distance is defined as D8 of PQ is equal to max of modulus x minus s comma y minus t. See here, pixels with D8 of P is equal to 1 as 8 neighbors of P. Okay, I think you will get a clear idea about relationship between pixels in image processing. Thank you. Thank you for watching.